This example asks us to determine all relative extrema, so relative maxes and mins is what they mean by that, and the intervals where the function is increasing and decreasing. Whenever I see that language, relative extrema or intervals of increasing and decreasing, those are bells and whistles going off telling me that I need to run a first derivative test. So those are kind of our key terms to tell us we got to run a first derivative test. First derivative test is a set of steps. It's the same steps every single time you do it. It's one of those really nice things in math where once you get the steps down, you just, practice them and you can do it again and again over and over. Step one of the first derivative test is, guess what? Find the first derivative. So find your f prime of x. We've got our equation given to us. We have f of x equals x to the 5/3 power plus 10x to the 2/3 power. So to find our derivative, that's just a bunch of stuff being added and subtracted. So we're just going to go ahead and do our power rule. So we bring the power down. We bring 5/3 down. X, subtract 1 from the power is going to get us x to the 2/3. Do the same thing here. Bring the power down. We get 2/3 times 10 is going to get us 20/3 x. Subtracting 1 from the power is going to get us x to the negative 1/3. So step 1 complete. We have found our derivative. Now, step 2 of the process is we need to go find critical values. Critical values occur when two things happen. They occur, the first one most everybody remembers, they occur when our derivative equals 0. The other place they can occur is when our derivative is undefined. And one of the common places to see that is when you get division by 0. So if you've got a fraction in your problem, you really have to concern yourself with, do I have the situation where I could get division by 0? So let's kind of go through this. We'll set up the first one, the one that everyone knows. We're going to take our derivative and we're going to set that equal to 0. When you come through to do this, you want to look out for negative exponents. I always tell people negative exponents are great for doing calculus. They are horrible for doing algebra. So to undo that rewrite right there, to put that x where it belongs, we move that x to the bottom. And that's going to turn this into 1 over x to the 1/3. So we push that x down to the bottom of the fraction, and that gets rid of the negative exponent. So that's just going to be a rewrite. Always look out for that. What that rewrite now allows us to see is that, unbeknownst to us, we do have a fraction happening in this problem here with an x on the bottom. And that means we have to worry about where would that portion of this problem equal 0, because that would make this undefined, and that would be a critical value. So here what you're going to do is you're just going to pull that one piece, just the bottom of the fraction, 3x to the 1/3, and you're going to set that equal to 0. Because whenever that happens, your derivative is undefined. Now we'll just do a little bit of algebra to get that x by itself. So divide by 3, divide by 3. We get x to the 1/3 equals 0. To cancel out that 1/3 power, we need to make this x to the first. So what do I multiply by 1/3 by to make it 1? I multiply by 3. And then whatever I do to the other side, so you raise it to the power. So powers to powers are a multiply game. So that's what I mean by multiplying those things. And so that ends up getting me 3 times 1/3 gets me x to the first, 0 to the third gets me 0. And I now have one of my critical values. Always make sure you check on this undefined one that it actually is in the domain of your original equation. And because we didn't have any fractions in the original equation, that critical value is there. Now we go back to where we were with the set it equal to 0 game. And so from here, we're just going to do our algebra to get x by itself. So we'll move this 20 over 3x to the 1/3 to the other side. So minus 20 over 3x to the 1/3. That'll give us negative 20 over 3x to the 1/3 equals 5 over 3 times x to the 2/3. We need to get that x out of the bottom now. We're trying to solve for x. So to get this x out of the bottom over here, we multiply it by x to the 1/3. So then whatever we do to one side, we have to do to the other. Cleaning that up, we're now looking at negative 20 over 3 equals 5 over 3. And then when you have like bases, you add those exponents. So 2/3 plus 1/3 is actually going to get us x to the first. And now we just need to get that x by itself. So the last move here is to go ahead and multiply by that reciprocal. So multiply by 3 over 5. Whatever you do to one side, you have to do to the other. And so cleaning this up, the 3's will cancel, the 5 cancels, leaving us a negative 4, and then all of this cancels, and we end up with x equals negative 4 as our other critical value. So we've got our two critical values, so step 2 of the process is complete, and now we are on to step 3. Step 3 is where you're actually going to do the first derivative test. And this is just a number line game. So you're going to lay out your number line, and now you're going to come back and you're going to mark those critical values on the number line. So I've got a critical value at negative 4, and I've got a critical value at 0. After that, you need to choose test values. So we need to choose a value to the left and to the right of each of these in the different intervals we created. So to the left of negative 4, I'm going to choose negative 8. That's a test value. In between negative 4 and 0, I'm going to choose negative 1 for my test value. And then after 0, I'm going to choose 1 for my test value. So this is a first derivative test. So we are going to test everything in the first derivative, right? Math people are not creative namers. So we have our first derivative over here. That's what we're plugging everybody into. So we want to know, what does f prime of negative 8 equal? What does f prime of negative 1 equal? And what does f prime of 1 equal? And so we are plugging all of those back into our derivative. So do that on your calculator however you need to. When you plug in negative 8, you should get out 10/3, a positive 10/3. We don't really care much about the number, we just care whether it's positive or negative. So it tells us that it is positive on that interval, which means our graph is heading up and increasing. And I always draw myself a little arrow there. It helps me to remember what direction the graph is going. It kind of gives me a little bit of the shape. Plugging in negative 1 to that equation, and we're going to end up with negative 5. So on that interval, it's negative, and therefore decreasing across there. So I just draw myself a little down arrow. Then we go ahead and plug in 1, and we get out positive 25 over 3. So this is now positive, and therefore increasing coming out of there. So from that first derivative number line, we can answer all our questions. We can even see sort of the general shape of our graph. You can kind of say, oh, my graph has got to go up and then down. So looking at that little line I drew, you can see clearly, oh, I've got a max that's going to be happening at that critical value, and then I'm going to have a min that's happening at this critical value. So once you have your first derivative tests complete, now what you want to do is you just want to come back through and answer whatever the actual questions are. So the first thing they want to know is, what are the local extrema? So they want to know basically, what are the local maxes or relative maxes, and what are the local mins or relative mins. It all means the same thing. So local maxes are going to happen when our graph goes from an increasing section into a decreasing section. It gives us that shape there. We saw when we drew our picture, we already know where that's happening. That's happening at x equals negative 4. Then to find your local min, you're looking for where the graph is decreasing and then changes back up to increasing. That we saw when we did our little sketch, that this is happening at x equals 0. So that's where those things are happening. That's when the local max and the local min are occurring. If you need to know what the actual local max or local min is, what the maxes and the mins are, the y values. So to get those, you would come back and you would plug negative 4 back into the original equation to get the y value that goes with that. You would plug 0 back into the original equation to get the y value that goes with that. So if you plugged in -4, you're going to end up, this one's going to be nasty. It's not going to be a clean number. It's looking like 15.119 when you plug that in. So that is your max value. That is what the max is. The x was when it occurred. So our max value is 15.199, and it happens at x equals 4. Plugging in 0, or x equals -4, excuse me. Plugging in 0 to our equation, we get out 0. So this is our min. That's our local min value. That's what the min is. And it happens at x equals 0. So that's when it occurs. So those are our local maxes and mins, our relative extrema. And then we come back and we just need to find where our function is increasing and decreasing. So again, read your info off of your first derivative number line. So I can see from there that my graph is increasing, starting at -infinity and then ending at my critical value of -4. So -infinity, infinity never gets a bracket. That's always a parentheses. And then at -4, it's not increasing any longer. So you would close that off with another open parentheses, not a bracket. And then we do this union symbol, which means connect it to. And then starting again at 0 and heading off to infinity, this is increasing again. So starting at 0 but not including 0 and heading off to infinity. Then the decreasing section is going to be that section in the middle here. So in between -4 and 0, that's where we had a negative derivative. Our graph was headed down, so -4 to 0 is where we're looking at a decreasing section. So this is just a classic first derivative test. Same steps every single time. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.